Example 10, we're back finding the equation of a tangent line to the graph of another quotient of two functions, e to the x, divided by 1 plus x squared. Hi, Rowan. At the point 1 comma e over 2. This one should be fun because who likes to take the derivative of e to the x? Everybody who understands the derivative because it's the easiest one. All right, coming back over here, let's get rid of orange. Nobody wants the orange. We want the, nice blue that matches this color of blue. See, you can't even see me coloring in the 0 because it's a perfect match. Anyway, all right. So can we rewrite that one before we start to avoid the quotient rule? No, I mean, you could rewrite it as f of x is equal to e to the x times 1 plus x squared to the negative 1 power. But as I told you in the previous video, you have a function inside of a function. It's a composite. You can't take its derivative without the chain rule, which we do not know yet. Be patient, please. One thing at a time. All right, so taking the derivative with the quotient rule goes like this. F prime of x is equal to the derivative of the top. Derivative of e to the x is e to the x times the bottom 1 plus x squared, minus the top e to the x times the derivative of the bottom, which is a 2x, all over the denominator squared, 1 plus x squared squared. Okay, maybe clean this thing up. Notice that there is a common factor across the top here, so I'm going to factor out this e to the x here, and then clean up the rest of it. And 1 plus x squared minus 2x. You know what? I've got this feeling that the top factors doesn't factor in such a way that it's going to cancel anything out, but, it'll look prettier. Like, I can rewrite this maybe, or x squared minus 2x plus 1, and then see that that's a perfect square right up there on top. So the derivative is equal to e to the x 1 plus, x plus 1 squared over 1 plus x squared squared. And there you have it. Nothing cancels. Why did I find the derivative? I found the derivative so I can find the slope of the tangent line, specifically at x equals 1. I have the y-coordinate already given to me, which is nice. I just have to find the slope at that point. So I'll plug it into the derivative. Prime of 1 is equal to e to the uno times... Oh, you know what? I think I made a fatal error here. I did make a fatal error. This should be in a negative 2x. X minus 2x, which makes this an x minus 1 squared. Oops. I would have done this whole entire thing wrong. Had to re-record this video. Okay, so we're going to pretend like I did it correctly the whole entire time. Okay, so now plugging in 1 here. 1 minus 1. That one gives me 0 squared over. Does it really matter what the bottom is? As long as it's not 0 also. 1 plus 1 squared pretty much is going to be just equal to 0. We did it again. We went through all of this work and we got another slope of 0. It's another horizontal tangent line. And as we said before, if you have a horizontal tangent line, it's supposed to be just y equals b, so y equals the y-coordinate. So for us, that's y is equal to e over 2. And we are done with this problem. I mean, maybe we want to examine the graphs thusly. So here's the graph of the... Whoa, that's weird. Okay. And then here's the graph of the derivative. That's also super weird. And then here, let's go ahead and graph in our horizontal tangent line that we just found.